Hello everyone. In this video, we're going to learn how to integrate the square root of tangent s ds. Alright, so we're going to start off with substitution. Alright, so we let t equals square root of tangent s. Then we're going to take derivative both sides, right? Before we're going to take derivative both sides, we're going to square both sides first. Alright, so it could be t squared equals tangent s, right? And then we're going to take the derivative both sides, so it could be 2t dt equals secant square s ds, right? Alright, so we know that secant square s equals tangent square s plus 1. So I'm going to replace this one with 1 plus tangent square, right? So I have 2t dt equals 1 plus tangent square of s ds, right? Alright, but we have t square equal tangent s, so tangent square is to be t to the 4, right? So I'm gonna divide both sides by 1 plus t to the 4, so I have ds equals 2t dt over 1 plus t to the 4, right? So I'm going to substitute over here, so I have the integral of t times 2t dt over t to the 4 plus 1, right? So I'm just simplify this one, so it turns out to be 2 So I just simplify this one, so it turns out to be 2 the integral of t squared dt over t to the 4 plus 1. I look at this one, I see that 2t squared, right? So I just rewrite this one as t squared and t squared right here, right, over t to the 4 plus 1 dt right here. Now I just subtract 1 and then I'm going to add 1, right? And then this one turns out to be 2 integral. The first one is going to be t squared minus 1 over t to the 4 plus 1 dt plus the integral of t squared plus 1 over t to the 4 plus 1 dt. So I name this guy. The first one, I'm going to name this one as m. The second one, I'm going to name this one as n. So I need to calculate each of them and then I'm going to add them up, right? So I need to calculate m first. So m equals the integral of t squared minus 1 over t to the 4 plus 1 dt. Alright, so in order to calculate this integral, I just divide the top and bottom by t squared. So it turns out to be the integral of 1 minus 1 over t squared over t squared plus 1 over t squared dt, right? Now on the bottom I just add and subtract 2, right? So it turns out to be a complete square right here, right? For the first 3 terms right here, it turns out to be a complete square. So this one turns out to be the integral of 1 minus 1 over t squared over t plus 1 over t altogether square minus 2 dt, right? Now I'm going to use substitution. So I'm going to let u equal to t plus 1 over t. Then I'm going to take the derivative both sides. So du equals 1 minus 1 over t squared altogether dt, right? So I substitute back over here. So I have this guy becomes the integral of du over u squared minus 2, right? So this one turns out to be the integral of u minus root 2 times u plus root 2 du, right? Okay, so I'm going to use the decomposition method to decompose this rational function right here. So what should I do? So I observe that 1 over u minus root 2 minus 1 over u plus root 2 equals. Alright, so I just cross multiply this, right? This one right here. So it turns out to be u plus root 2 times 1 is going to be u plus root 2. Now u minus root 2 times negative 1 is going to be negative u plus root 2, right? Over u minus root 2 times u plus root 2. Alright, so if I simplify this one, it turns out to be 2 root 2 over u minus root 2 times u plus root 2. Alright, so in order to decompose this one right here, I'm gonna multiply the top and bottom by 2 root 2, right? So this one turns out to be 1.5 root 2, the integral of 2 root 2 over u minus root 2 times u plus root 2 du, right? Alright, so I'm going to decompose this one. So it turns out to be 1 over 2 root 2 of the integral 1 over u minus root 2 du minus the integral 1 over u plus root 2 du, right? This guy right here. Right, I just decompose this one to this one. Alright, so keep in mind the integral of 1 over s plus a ds is going to be natural log absolute value of s plus a plus c, right? So this one turns out to be 1 over 2 root 2 natural log of absolute value of u minus root 2 subtract natural log of absolute value of u plus root 2, right? Plus c, right? So don't forget parentheses for this guy right here. Alright, so I'm going to use logarithmic properties. So if I have log base a of b divided by c, and then this guy turns out to be subtraction, right? So log base a of b minus log base a of c. Alright, so I apply this formula. So it turns out to be 1 over 2 root 2 times natural log of absolute value of u minus root 2 over u plus root 2 plus c. Now I need to substitute this guy back over here because u is equal to t plus 1 over t. But t equals square root of tangent s, so I have 1 over 2 root 2 natural log of absolute value of square root of tangent s plus 1 over square root of tangent s minus root 2 over square root of tangent s plus 1 over square root of tangent s plus root 2 absolute value and then plus c. Alright, so we just calculate m equals 1 over 2 root 2 natural log of absolute value of the square root of tangent s plus 1 over square root of tangent s minus root 2 over square root of tangent s plus 1 over square root of tangent s plus square root 2, right? Now we're gonna move on to n right here. So n equals integral of t squared plus 1 over t to the 4 plus 1 dt, right? So we do exactly the same thing, so we just divide the top and bottom by t squared. So it turns out to be the integral of 1 plus 1 over t squared over t squared plus 1 over t squared dt, right? So the bottom right here, I just add 2 and I subtract 2, right? Right, so it turns out to be the integral of 1 plus 1 over t squared over t minus 1 over t altogether square plus root 2 altogether square, right? dt, right? So we're gonna let u equals t minus 1 over t, then du equals 1 plus 1 over t squared dt, right? And then we substitute over here, so we have the new integral. It's going to be the integral of du over u squared plus root 2 altogether square, right? So we know that the integral of ds over s squared plus 1 is going to be tangent inverse plus c. The integral of du over u squared plus a squared is going to be 1 over a tangent inverse of u over a plus c, right? So this guy turns out to be 1 over root 2 tangent inverse of u over root 2 plus c. Now u equal t minus 1 over t, but t equals square root of tangent, so this guy turns out to be 1 over root 2 tangent inverse of square root of tangent s minus 1 over square root of tangent s over root 2 plus c, right? Alright, so we're gonna combine. So finally we have I equals m plus n. So m equals this guy right here. So it will be 1 over 2 root 2 natural log of square root of tangent s plus 1 over square root of tangent s minus root 2 over square root of tangent s plus 1 over square root of tangent x plus 2 root 2, right? So this is for m. Now n is going to be plus 1 over root 2 tangent inverse of square root of tangent x minus 1 over square root of tangent x over root 2 plus c. And this is the final answer. And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.